I'm really thrilled to introduce Kevin Arizmendi to you all. I'm really happy that he's joined this team. He was a student at Santa Barbara City College, and when he was taking animal biology, he expressed an interest in corals because he was working at the Natural History Museum's Sea Center, and they got a little coral tank. And so, because he heard that I work on corals, he approached me, and so I pulled him into the ranks. And this guy is awesome because he really, I mean, it's really hard. Corals are hard to identify in general, but to try to do it over just photographs and not great photographs at that was a real feat. And Kevin worked diligently to learn all of the different coral species and learn how we collect our data when we're out in the field in Micronesia, and then tackled this great project that we had sitting with all of these photographs of the quadrats from corals from the year that we couldn't get to Ulithi ourselves. Nicole and I are usually the ones who are collecting the benthic data, but we were busy in the outer islands. And so Giacomo was in Ulithi alone, and he was counting fish, and he quickly took as many pictures as he could of the quadrats. And so we had these piles of photographs, and I was having a really hard time myself getting around to analyzing them. And so Kevin was such a help in being able to analyze them with me, and so much fun to be able to talk about corals and reading papers to enhance understanding of corals. And so it's grown, and some of you have joined in on our coral discussions, and so it's a really great group. So Kevin, once he analyzed this first batch and was eager to keep going, I told him it was time for him to start doing the next phase of being a scientist, and that's putting the data together and telling a story. So we chose a very clean little piece, this really curious thing that's happening in MogMog, and it was my hope that Kevin could present it in person at this conference, the Western Society of Naturalists. But unfortunately, we had to be online for COVID. But sometimes that's good because it allows one to reach a broader audience. And so your first scientific conference, even though it was virtual, you got to present this really amazing poster that came together. So I don't know if there's anything else you want me to say about Kevin, who is now a student at UC Santa Cruz and studying oceanography. And hopefully we can get him to Ulithi someday to see these corals in person.
So I guess I'll just get started. Like Michelle's been saying, I was from Santa Barbara City College, transferred over to UC Santa Cruz, and then studying oceanography. So here's my presentation: the typhoon effects on a weedy coral, post-typhoon coral reef recovery, positive impact for previously outcompeted species. Before I start, I'm just going to give some important background information. So we're going to be looking at where we are. So this right here is the Ulithi Atoll. It's in the Indo-Pacific. And as Michelle was saying, we're going to be looking at this island right here, which is MogMog. Then here we have an aerial drone shot. So here we have a benthic quadrat, which is around 5 by 5 meters. And the way we collect our data is we basically add up the percentage of what is being covered. So here you can see some weedy coral. It's roughly maybe like 15 to 20%. Here we have some other coral colonies that are, somewhere between 5 and 10%. But you'll see that most of this quadrat itself is covered in this kind of brownish greenish carpet looking stuff. And this is all algae. More importantly, this is all turf algae. And what eats turf are herbivores, like this guy right here. So this is a parrotfish. So herbivores like parrotfish eat algae, which frees up space for corals to grow on a reef. Algae and corals are always constantly competing for space. Algae have the potential to transmit coral diseases and poison coral tissue. So having herbivores greatly reduces this from happening. And you'll kind of hear me say weedy coral, and you're kind of be like, what am I talking about? So what coral I'm talking about specifically is Montipora. So this right here is an example. This isn't in MogMog, but this is still in Ulithi. So you can kind of see how it's been growing in an outbreak. We dubbed it Outbreak Montipora. And the really weird thing about it is that it's really good at outcompeting other coral species. So here on the right, you can kind of see how it's crawling on some substrate and kind of, I guess, encasing the Acropora, which is this coral right here. We'll go over Typhoon Maysak. So this right here is the typhoon in motion. And then here you can kind of see it going through Yap and Guam. And in 2015, Typhoon Maysak had devastating effects on the Ulithi Atoll. Interestingly enough, it also had some impacts on the coral reef as well. So we're going to be looking at what happened. So what happened to the corals? Well, you can kind of see here that before Maysak, a lot of the coral cover itself was just basically outbreak Montipora. After Maysak, Maysak basically just obliterated the reef itself. So you can kind of see in 2015, outbreak Montipora isn't there. It's kind of just Porites. In 2016, it kind of bounces back a little bit, but there's other coral genera. So we have some Goniastria, we have some Passalopora, we have some Samacora, and then 2019, you can kind of see that there's a lot more different corals now. So you can see that Acropora had a giant jump. You'd see that Montipora is still there, but it's not as big as before. You'll see that there's Porites, Goniastria, and a bunch of other different corals. So basically, after Maysak, all these different coral genera started appearing, and then the coral cover started to become a little bit more diverse. So we wanted to see what the growing conditions were like after Maysak. So this pink line right here that you see, this is crustose coralline algae. We refer to it as CCA. And what the CCA is, it's a good indicator for coral growth. A bunch of coral larvae will kind of embed themselves in the CCA, and it's a really nice growing condition for them. You'll see that after Maysak, CCA starts to go up, and then basically outbreak Montipora starts to go down. So CCA had a gradual increase as Montipora outbreak became less dominant. So what did the coral colonies look like after Maysak? So after Maysak, you can see that there's more coral genera. In specific, you can see that other coral genera like Acropora do really well, Samacora does really well. But before that, there was only kind of just two species or genera. You can see Isopora and Porites are the only ones before Maysak. After Maysak, a lot more coral genera start to appear. So something that was really interesting that we saw in the data was if coral genera are increasing, why is the coral cover percent so small? And it was kind of a lot for us to think about, and we came up with this. So the reason why the percent cover was really small is because most of these corals are still juveniles. And although they're juveniles, the recruitment of the coral starts to increase year after year. So these corals can be either branching corals or these large table corals, but it takes a long time for them to grow. So even though they're really small, it's really good that there's a lot of different types of corals appearing after Maysak. So what do these different corals do physically to the reef? So here we have two pictures. So the one on the left is MogMog in 2014, and the one on the right is MogMog in 2019. So the reduction of outbreak Montipora can cause a phase shift, where on the left we have a less diverse reef, and on the right we have a more diverse reef. And this is basically due to the complex structures that corals. So if I was a fish on the right, there would be more spaces for me to hide in. So I can either hide under a table coral, or there might be some places behind a mounding coral where I can hide in. And this increase in structural complexity brings in more other organisms, either fish, invertebrates, what have you. And this increase of structural complexity, one, increases the biomass, so other animals start to come in, and two, it also supports people who rely on these reefs as a resource. So we also wanted to see how these changes affected the reef biologically. So here we actually have a juvenile Acropora colony, and then right next to it, you'll see this little snail. So this is a trochus snail, and these trochus snails started to appear more after Maysak, which means that more of these coral Acropora colonies started appearing. And because of that, other animals started coming back, like these trochus snails, which typically only feed on Acropora. So it was, for us, it was an indicator that the corals are, recovering, which means that the system as a whole is also recovering. So something that you might have noticed at the graphs, if you looked at them carefully, is why was there a decline of outbreak Montipora before 2015? So this is what I'm talking about right here. So you can even see that outbreak Montipora was already kind of decreasing before 2015, and CCA was already increasing before 2015. And there's an important reason behind this. The reason why there's a decline of outbreak Montebro before 2015 is the community. The community's actions induced this outbreak Montebro decline. So what were the effects of the community on the reef? So what in 2013, the community of MogMog came together and they restored traditional fishing practices. This led for them to have a recovery of important fishes such as herbivores. I talked about earlier that herbivores are important because they support coral growth by reducing the amount of turf algae or any other algae that kind of stresses them out and competes for space. And because of this freed up space, the corals are able to grow, and their favorite growing conditions, the CCA, is able to increase. And I really want to stress that this is important. Because of their diligent work, outbreak Montebro was already on a downward trend, and CCA was already going to increase anyways. Typhoon Maysack kind of basically just accelerated that growth. So the community's actions and Typhoon Maysack had a synergistic effect and kind of made this phase change from a less productive reef into a more productive reef. That's my presentation. Are there any questions?